I literally found the best way to add real-time functionality to any web application, including Next.js. Now, most people implement the classic setup. This means one simple Express server with socket I/O. Sure, that works, but once it's time to scale, your application will fall apart quickly.
Oh no! Oh no!
So, what do? Add multiple servers, sync them with Redis? Sure, again, that works, but it's hard to maintain and honestly, it's quite messy. And this brings us to the main question. Is there any solution that scales infinitely, is easy to implement and runs on your infrastructure? Well, thankfully there is, and it's powered by something called durable objects. But before we dive into them and create an actual real-time chat application, let's firstly take a step back and explore all of the options that you have for building real-time applications. So, without any further ado, let's go! Alright, so let's first of all start by looking at the simplest example, the most common one and the easiest one to implement. And this makes use of a separate real-time server. In most cases, I, for example, use Express with socket I/O enabled, configured, installed, whatever. But you could also use PHP. It does not really matter, but since I'm a JavaScript developer, in most cases I would use Express. In theory, I could just use the Next.js backend, but since I deploy my applications in most cases to Vercel, I don't get access to any long-running tasks, which means I need a separate server. So this real-time server now uses Express, socket I/O, and it's deployed to Hetzner, for example, to get the benefit of a serverful deployment. And now, how does this workflow look like? How does it work? Well, my Next.js front end will make a request to my backend. Let's imagine I have a chat application. This means I will tell my backend, hey, we have a new message. Let's store it in our database. So in theory, my backend will make a request to my database and store the new message. But as you all know, this is not real time. This is just a simple DB transaction. We want to now also pretty much broadcast this message to all of the other clients. And that's why we will now make use of our real-time server. My backend will pretty much make a post request to the real-time server and say, hey, we have a new message and I want you to broadcast this message, this event, to all of the connected clients. So our Next.js front end has some sort of room, you could say unique identifier. So if we have a chat application, then this chat application in most cases has certain rooms, channels, whatever. Let's imagine that we are currently connected to the room 123. And this real-time server will now say, hey, so we have a new message for the room 123. Let's broadcast this event, this message to all of the clients which are connected to this room. So the Next.js front end will be connected to the server and the server will then broadcast this message to all of the connected clients for this specific room. And that's already it. As you see, it's a very simple workflow and it's actually very simple to implement. But this has a huge problem. This is not scalable. Let's imagine you at some point get Facebook scale. Do you think that one server will be enough? No, at some point you will hit the limit where it won't work anymore. And that's where you will have to look at scaling options. And the most common option is to, well, add more real-time servers to pretty much balance the load. So in this case, again, I have a Next.js front end. The front end makes a request to my backend. The backend, in theory, will make a request to my database to store the message. And then instead of hitting the real-time server, we want to actually emit the event to Redis. Because here's the problem. We now have multiple servers. And these multiple servers don't really talk to each other. They only talk to the front end. We balance the load. This means multiple servers can be connected to one client. Let's again imagine the following. This is room 123. And for example, this server has 5 connections to this room. And then this server has only I don't know, 1. How do we now tell this server to broadcast the event and also this server to broadcast the event? Well, we need some sort of middleman, something that synchronizes everything, something that pretty much orchestrates all of the events, if this makes sense. So in this case, we will use Redis. Redis will get this event. Our backend will emit the event. Hey, new message for room XYZ with the content XYZ. Redis will get this new event, and then it will actually pass this event to our servers. So it won't only pass it to one server, but in this case to this server, and then also to this server. All of these servers will get this new job, and then we will see, okay, this one server has 1 connection and this server has 5 connections. This means this server will broadcast the event to all of the 5 clients, and this server will broadcast the event to 1 client, because there's only 1 connected client. And you know what? This is a great solution, because this can pretty much scale infinitely, because you can pretty much add more servers if you have more load, and Redis also is quite reliable. Nevertheless, this solution, this architecture, still has a lot of problems. Let's look at the problems in more detail. First of all, this whole array, this whole configuration is stateless by default. What I mean by that is pretty much expressed with socket.io. You need Redis, ADB, or some sort of custom in-memory sharding setup to handle shared real-time state. That's what I explained right here with Redis. We need a middleman. Secondly, our servers are deployed to a single region. So in most cases, you will probably choose US East 2, for example. But let's imagine that you have users from India or Japan or from Germany. These users will encounter higher latency. You don't really want that. You want to have a solution which is distributed globally, pretty much on the edge. You want to use edge computing. Another big problem is local first development. Let's be honest with each other. Local first development with 1 real-time server is relatively simple to implement. It's not groundbreaking, but imagine having 50 servers. Implementing local development isn't as simple anymore. Implementing all of these servers isn't as easy anymore. Managing all of this is quite complicated and takes a lot of time. And here's the biggest thing. It will become very expensive, because you now not only pay for 1 server, you pay for multiple servers, plus Redis of course, but Redis is relatively cheap. Another problem is of course that you have to set up WebSockets yourself. This is a one-time thing. Once you implemented it, it's quite easy going, right? Because there's no maintenance, but it again takes a lot of time to set everything up, reconnection, disconnection. It's annoying, and well, scaling is also annoying, because you have to always pretty much add new servers or remove servers, update the RAM, update the CPU, stuff like that. So honestly, if you work at Facebook or Meta, I'm sorry, then sure, that's fine, this works. You have a lot of co-workers which can help you, but if you are a solo developer with quite some load, then yeah, I'm sorry for you. No, I'm joking. So all of these problems pretty much led me into a rabbit hole of finding the perfect solution for me. I wanted something that is relatively simple to implement, something that is distributed globally. I want to use edge computing. I wanted to use something which can run on my infrastructure. I didn't really want to use a third-party service, and it should be quite cheap. Something like serverless functions. Something quite small, cheap, easy, fast. But thankfully I found a solution which ticks all of my boxes, and it's called Durable Objects. So Durable Objects is a product by Cloudflare, and it's very similar to serverless functions. So what's the biggest problem with serverless functions? Well, they are stateless, and they pretty much spin up, and once the request is served, they again shut down. They are stateless, no memory, they don't run for a long time, they don't work for real-time applications. But durable objects are very similar in the idea that they are pretty much serverless functions, but in this case they are stateful and they handle memory. So here I created a few bullet points. So first of all, they are stateful server objects that run on Cloudflare's edge network. This means closest to the users. The problem with our server full deployment was that we were bound to one region, US East 2. But with durable objects, they are distributed globally, which means if a user makes a request from Germany, he will also be served from Germany using the edge network. Secondly, each object has a unique ID and it lives in one location, keeping shared state consistent for everyone accessing it. And this is a huge benefit because this means that we don't need a middleman anymore. We don't need Redis to orchestrate, synchronize everything. No, we only need our durable objects, as you see here. Another thing is that they are like mini servers, like serverless functions that are managed by Cloudflare so that you don't have to worry about scaling, failover or infrastructure. Everything is done by Cloudflare, and as you all know, it's quite cheap and they have a very generous free tier. And unlike serverless functions, which are stateless, durable objects can store memory and logic between requests. So to summarize it, I know this sounds a bit complicated if you are new to durable objects, but think of them like serverless functions which are distributed globally. They can store data and they are a great solution for serverless applications. Now, if durable objects still confuse you, then please just head over to the documentation. Then you will find the section what are durable objects, and this will explain it quite well. Oh, and by the way, this is not sponsored at all. And now, how exactly does the workflow look like and how does it work? So we again have our front end, and let's imagine we have a room, or this client is now connected to the room 007, James Bond, and then we have, let's say we have multiple clients, so user 1 and then also user 2. They are both connected to this one room. Our front end will now make a request to our back end to store the message in our database. Then our back end will make a request to a durable object. So here's the thing, durable objects are unique, so each object is unique, it has a unique ID. In this case, this could be 007, and this durable object could have the ID 123, so they are all unique and they handle unique events. So since we get here a new event for the room 007, this single durable object will pretty much respond. It will then create a connection, or I guess it's already connected to the front end, and it will broadcast this message to the connected clients. In this case, we have two clients, so it will pretty much broadcast the message to these two clients. If we get a new event for the room 005, then another durable object will respond. In this case, let's say this one, because this now has the unique ID 005, it will get this new event and it will respond to the client. So each durable object is unique and it handles a unique, you could say, room ID. So here they have a beautiful diagram which explains it very well. So we have multiple clients, and this one client is, for example, connected to the room 001. And then we have one durable object, let's say also with the ID 001, and then this will respond to this specific client. Now let's say we have two more clients and they are connected to the room 002. So two clients for one room. We will now have one durable object, not multiple ones, no, one durable object. And this durable object will have the same ID and it will respond to these two connected clients. In this case, we now have three clients, and let's say they are connected to the room 005. This server will now also have the same ID and it will respond to these three clients. So this is the architecture of durable objects. It's super powerful. It's automatically distributed. We don't have to add any Redis synchronization, load balancers, nothing like that. Everything is done for us. We just have to add the specific ID and then that's already it. Scaling is done for us. Distribution is done for us and everything like that. So to summarize it, you could say that this architecture using durable objects objects is the best of both worlds. We get the scalability of the advanced example while having the simplicity of the simple example. Because what was the main problem with the advanced example? Well, we had multiple servers which could be connected to one, for example, room. So these two servers are connected to the same room to pretty much balance the load. This is great for scaling, but it's hard to maintain. That's why we needed the middleman, Redis. But since we use doable objects, each object has a specific unique ID. So this, for example, room or this object will handle the traffic for one specific room, 007, this one for 005, this one for 123, this one for 555. This means everything is distributed, everything is pretty much handled for us, and we have to just create the code, maintain the code, that's it. So now you might say, great, let's use doable objects. Well, there's only one problem. Let's again look at our problems. So local first development is fixed. It's quite simple with Cloudflare. Stateless by default is fixed because it's stateful. Single region is fixed, well, because doable objects are distributed. Scaling is fixed because scaling is done automatically by Cloudflare. There's only one problem left. Set up WebSockets yourself. The thing is, Cloudflare durable objects are great, but WebSockets is still something that you have to set up. So it's quite similar to the Express server example. We had to implement Socket.io. In this case, we have to do something similar. But I will be honest with you, I don't want to do that. I would love to have the simplicity of a third-party service while not using a third-party service. I don't want to pay a middleman. I want to use Cloudflare durable objects natively while having a simplified API which already implemented all of the WebSockets, reconnection, disconnection, stuff like that. But again, the most important thing is I want to use it natively. I don't want to pay extra. So is there any solution which is pretty much a framework built on top of Cloudflare durable objects? Well, thankfully there is, and it's called PartyKit. So PartyKit got, I think, released about 2 or 3 years ago, and it got acquired a year ago by Cloudflare. So it's pretty much an open source deployment platform built on top of durable objects. It's not a paid service, so if you go to the pricing, you will see it's free, and it's also free for commercial use. You have to just deploy it to Cloudflare. That's it. Oh, and again, this is not sponsored. This is open source, it's cool, and that's why I'm showing it to you guys. But now you might ask me, hey Jan, why should I use PartyKit? Why shouldn't I just use raw durable objects? That's a good question and a valid question. So first of all, as you know, PartyKit is built on top of durable objects. This means it's just a higher level abstraction. You still use durable objects. You still deploy your code, you could say, to Cloudflare. So durable objects are quite low level. You have to manage message routing, WebSocket upgrades, and state coordination yourself. PartyKit, on the other hand, provides friendly APIs that just work for real-time connections so that we can focus on features instead of plumbing. That's a huge benefit. Another benefit is automatic WebSocket handling. With durable objects, we have to create the logic by ourselves. This means upgrade logic, connection logic, disconnection logic, and stuff like that. PartyKit, on the other hand, manages everything. So every room is a durable object. So looking at our diagram again, we have multiple rooms. Room 1, 2, 3, 4, 5. Each room is now a durable object. And then this durable object, this room, has WebSocket support built in. Another benefit is local development. So here's the thing, local development is also quite good for raw durable objects. You just have to define the Wrangler CLI, but it's quite okay. It's simple enough. But PartyKit is even simpler because it gives you a dev server and it works right away with zero configuration. It's a simpler mental model. In general, it's a higher abstraction, perfect for real-time applications, and that's what we want to build. So I created a relatively simple chat application. So here I have to join a room, so I can just generate an ID, this one, and I can join the room. Let me also copy the URL and open this specific room in a new tab, and here you already see heads up XYZ joined the party. Yoo-hoo! And if I now type a message, hello, how are you, mate, and send this, then my partner, okay, not my partner, but the guy on the other screen, will also automatically and instantly get the message. If I type something inside of here and click on send, voila, I automatically get the message. This here is real time, no syncing, nothing like that, just PartyKit, and that's it. So how can you implement PartyKit? Good question. Let's head over to the documentation. If you want to go through the documentation, it will again explain what PartyKit is, why you should use it, why it's cool, stuff like that. But we want to implement PartyKit into an existing project. So it's quite simple. You want to just copy this command, go back, and then paste it into your terminal. Once you do that, it will create one new folder, a party folder with an index file. This party folder is your server. This means inside of here, you define your server logic, which will run in the durable object itself. So how exactly does the code work? Good question. First of all, we export a default class called server and it implements party.server. What does this exactly mean? Well, let's go to the documentation, and here they have a documentation section for the server API. So first of all, we define the party server. This is a TypeScript module that implements the party server interface. Then as a next step, we create this constructor, read-only room, party room. So the party server constructor receives an instance of party room, which gives you access to the room state, to the individual room state, and resources such as storage, connection, ID, and much more. And let's again go back. So we defined a constructor. This is already defined when you pretty much run the command. And then we have this function onConnect. What is this? Well, onConnect is what will run once a new user connects to your server. So let's again go back, and you know what? I will go to the index page. If I generate a new ID and click on join, nothing happens, right? But if I open this room in a new tab, then I get a new notification. Heads up, XYZ joined the party. So this onConnection runs whenever a new user connects. And here I just say heads up, XYZ joined the party. And as you see here, I do two things. Connection.send this.room.broadcast. What does this mean? Good question. So connection.send sends the event to the user who joined the party or the room. In this case, I joined the party here on the left side, and this message would be sent to this user. And then we have this.room.broadcast, and this broadcasts the message to all users. And then we have this array, I call it a dependency array, and here we pass all of the connection IDs which we want to exclude. So in this case, we broadcast the message to all users in the room except the user who joined the party. So since I joined the party on the left side, I don't get this message. But if I open this also again in a new tab, then I get this heads up message because this new client joined this room. So this is this connection.send and broadcast. Broadcasts the message. Connection.send sends the message to the creator itself or to the person who pretty much created the connection. And inside of here, I use the serialize function. I will come to that in a second. That's not so important. As a next step, we have the onMessage method, and this is called when a WebSocket connection receives a message from the client. So in this case, we get a message which is of type string, and we get the sender information. information. First of all, I console log it, and then as a next step, I pretty much check what type it is. So I created a schema file with a client command schema and a server event schema. The client command schema is what the client sends to the server. The server event schema is what the server sends to the client. And I have multiple types. So first of all, a standard message, a system message, and a welcome message. So in this onConnect, we created a welcome message. That's why I have the type welcome. And then the serialize function pretty much just stringifies my message. So JSON.stringify, because you have to send a string, but we want to send an object. That's why we stringify it and then we send it. Then in this onMessage, I check what type it is. Is it a chat send? Is it a system message? What is it? What does the user want to send? In this case, the user wants to send a normal message. This means we construct the event with a type, with an ID, with the text itself, the room ID, the sender ID, the timestamp, and then we broadcast the message to all users. In this case, we don't exclude the sender ID, but in some cases you would maybe want to exclude the sender itself to do some optimistic updates and stuff like that. But in general, I send a message. So for example, hello. If I click on send, my server gets the message. This onMessage method runs. We know that the type is chat send. This means we construct the event and we broadcast the event to all clients. Now this is the server, but as you all know, we also need a client to send the event and well, to get the event. So let's go back to the documentation. Here they have a section on the PartySocket client API. So PartySocket is a TypeScript client library for connecting to PartyKit servers via WebSockets. So what are the features and why should you use PartySocket? Well, it's quite simple. It's compatible with the WebSocket API. It's one-to-one. It automatically reconnects if the connection is closed. It allows for multi-platform. It's dependency-free. It handles connection timeouts. In general, it's pretty much WebSockets on steroids, if this makes sense. So let's go back and let me show you how it works. So in my lib folder, I have a use PartySocket file, and I actually use the React version of PartySocket, because if you scroll a bit to the bottom, then you will find this section, usage with React. So PartySocket also exports a React hook for convenience. The use PartySocket hook handles connection on mount, disconnecting on unmount, and cleaning up the handlers. So inside of here, I first of all get two properties, the room ID and options. The room ID is needed to create a durable object, a unique durable object, because each durable object needs a unique ID. In this case, this will be room-the room ID, and each room ID is unique, which means my durable object is also automatically unique. Inside of here, we then have a few properties on open, on message, on close, and on error. In this case, on message is what will run whenever we get a new message from the server. So if I open the server, this is an event which we get from the server, a server event. I get it in this onMessage property. I pass the event because again, in my schema, I have a few helper functions, pass client command, pass server event. I now pass the server event to pretty much get the JSON structure, and then I return it. So let's go back to the use PartySocket. Here I just return it, options.onEvent, and I pass the event here. And then at the bottom, I also created a new function, send command, and this is what will be used to send a new event to the server. So I get the command, I serialize it, I stringify it, and then I pretty much just send this new command to the server. I return it here, send chat. This is a new function. I use the send command. The type is hard-coded, chat send. I pass the text and the room ID, which is very important because you need a unique identifier for durable objects to work. And now let's look at the UI. How did I connect everything? Well, it's quite simple. First of all, I have my local host, my index page. This is where I create my room because I need a unique identifier. So if I open my index page, I have a component room join form, and inside of here I literally just have an input which creates a new room with a unique identifier. Once a new room is created, I redirect the user to this new path. So in the app folder, I have this room ID route, and then I use the chat room component. This chat room component first of all gets the room ID from the params, because as you all know, I now store this ID here on the top in the URL. So this is my unique identifier. I get the unique identifier, and then I initialize the use party socket client hook. So here I pass the room ID as an argument. And then inside of here I have my on event property, and I check for the event type. If the event type is welcome, well then I don't really do anything. In theory I could console log it, but that's not important. I want you specifically listen for the event type message. That's when a user sends a message. And once a user sends a message, I just put the message into state. That's it, nothing groundbreaking. So this now automatically connects to the correct doable object using the room ID. And you might ask me, hey Jan, how do you send a message to the server? Well, again, you use the use party socket client. So if we open the use party socket client, as I showed you a second ago, we return this send chat function. This then calls the set command function, which pretty much just stringifies our JSON object, and then we send it to the server. And then here I just created an onSubmit function. I used the send chat and I passed the text as an argument. That's it. As you see, it's super simple. So to simplify it, we have one server, we have one client, and then we use the client in our UI. It then pretty much relays all of the info to the server, and the server then broadcasts the event to all of the connected clients using this room ID, which I pass as an argument. So let me again summarize everything so that you understand everything. We have a unique room, this one. This unique room has a doable object, one specific doable object connected to it. Once a user sends a message, we use the client which I created, so this use party socket, to send the command using party socket. It will send this, it will first of all stringify it, and then it will send it to our server. Our server will then check what type it is. In this case, we send a message, which means this case will pretty much, you could say, run. So we construct the event with all of the info which we got from the client, and then we broadcast it. And we broadcast it to all of the clients which are connected to this specific room, so to this specific room ID. And then in our chat room component, we literally just get the event, we check what event it is, and then we update our state with the new message. That's already it. As you see, it was super simple, and deploying it is even simpler. Because if you go to the documentation, they have a quick start guide. We already installed PartyKit. The next step is to run the dev server. I already did that. So in my terminal, as you see here, this is the dev server. Super simple, no configuration needed at all. I get my console logs, it works nicely, and deploying it is also super simple. You want to literally just use this command. It will deploy it to Cloudflare's environment, servers, Edge environment, network, and that's it. It's super simple. And let me quickly again showcase the schema, because this might be a bit confusing. So I have a client command schema and a server event schema. The client command schema is used on the client side. This is when I want to send a message from the client side to the server. And then the server event schema is used to send messages from the PartyKit server to the client side. So since I want to only send messages from the client side, I only have one type, chat send. But from the server, I want to send multiple types. Of course, my message itself, but also the system. This is this heads up, hey, user XYZ joined. So here you see it, XYZ joined the party. And I also have this welcome, which I don't really use. But that's why I have multiple types in this server event schema. And then I have two, you could say, helpers, which then pass the content. And yeah, that's already it. This is how you can create a simple real-time application using PartyKit. All of this code will be also stored in GitHub. You can check out the repo using the link in the YouTube description. Hit the like button before you check it out. And yeah, I hope you enjoyed this video. I hope you could learn a lot. PartyKit is definitely something that I can recommend, and I will also use it in my next long form video, which is almost finished. I'm finished with the code. I will start recording the video at the end of this week. And yeah, now enjoy your day and see you in the next one. Bye bye.